Oh, this is a walkway suspended by cables. So this is the walkway here, and it's been hanging by these cables here. There's forces upwards here on this thing, and there's obviously the downwards force in the middle. If you were to draw it in 2D, it would just look like this. There's upwards forces there, and there's a downwards force in the middle. It's asking, it's a concrete. Where do you put the steel rods? We know that concrete is weak in tension. Concrete is weak in tension. So as an exaggeration of this thing here hanging, it will kind of end up like this. It's an exaggeration, obviously, but that's the sort of shape it's going to make. It's going to have compression on the top, and it's going to have tension on the bottom. And it is weak in tension. So it needs to have those steel rods in the bottom. Only C has that answer. I'm going to do the last two questions as well for this one. Oh, this is another torque question. There's a beam, length 12 meters, mass 1200. So I'm going to draw that 1200 first, and 1200 will be halfway. It's 6 meters. 1,200 newtons. And here we've got 6,000 newtons. Which one of the options shows the force exerted on the beam, by the beam on pillar B? I'm going to do this two ways. Way one, this is Paul's method, a student in my class last year. He looks at this and he says, well, the total force downwards is 18,000 newtons down. Then he says, if everything was in the middle, there'd be 9,000 newtons on A, and there'd be 9,000 newtons on B. But everything is not in the middle. One of them is slightly to the side, so B will have slightly more. And then he'll look at the answers and say, which one has B having slightly more than 9,000? Well, not A, not B. It's either C or D. Let's have a look again. 18,000, that's the total newtons down. B's not going to have all of it. A's going to have at least some of it. So the answer must be C. That's Paul's method. That only works if there's one answer that's correct. But it's a quick way of rushing through these torque questions. The second way is actually just to work it out using your torques. So if we want to know B, that means we have to choose A to be the centre of rotation. And then we say things are going to be pulling it down this way, things are going to be trying to resist that. This is the clockwise, this is the anti-clockwise, and the equation we set up is torque clockwise equals torque anti-clockwise. The things in the clockwise direction, there's two of them, that one and that one, F times R plus F times R, and the anti-clockwise direction is going to be B, F times R. So the first one is here 12,000 times the distance is 6 meters to the center of rotation, plus 6,000, and the distance to the center of rotation is not 3 meters, the distance is from here to here, and that's 9 meters. And that equals the force from B, which we don't know yet, times, what's the distance? From here to here is 12 meters. So let's just work everything out. We get 72,000 plus 54,000. That equals FB times 12. And that is 126,000 equals FB times 12. Divide both sides by 12. FB equals 10,500 newtons, which is what Paul said we get. Alright, I see an arch, I see straight away I'm looking for something with compression. It's made of stone blocks, there's no cement to hold them together. Stone is used in arch because an arch requires a material that is strong under shear stress, strong under tensile stress, strong under compressive stress.